students, welcome back to this new session on mathematics. Here I will be continuing with the same Laplace transform problems. Here is one more important problem for you, that is find the Laplace transform of sine root t. Okay, for that you have to use sin x expansion, which is x minus x cube by 3 factorial plus x to the power 5 by 5 factorial minus so on. Okay, so with the help of that I have expanded sine of root t. As you see, you get such an expansion, and further I have just replaced root t by t raised to 1 by 2, or you can write root t whole cube as t raised to 3 by 2 divided by 6 factorial, because 3 factorial is 6, not 6 factorial, sorry, 3 factorial is 6, so we have replaced it by that. 5 factorial by 120, and to root t raised to 5 you get it as root t raised to 5 by 2 divided by 120. This is all you get about the expansion for sine root t. Okay, now I want to work for the Laplace transform of sine root t, which is equal to the Laplace transform of t to the power half minus 1 by 6 outside, the Laplace transform of t to the power 3 by 2 plus 1 by 20 again outside, and the Laplace transform of t to the power 5 by 2, and it continues so on, minus so on. Okay, I want, see, first I have to work all of these individually and then substitute back in this expansion. So I want t to the power half, which is nothing but, yes, so you can use this formula for that, I have already written. Yes, so Laplace transform of t raised to n as gamma of n plus 1 over s to the power n plus 1, where n is any real number. So here n is half, so you can write it as gamma of 1 by 2 plus 1 divided by s to the power n plus 1, which is gamma of s to the power half plus 1, or you can write this as, now again when n is any real number, gamma of n plus 1 can be written as n into gamma of n. So using that concept you can write this as half into gamma of half over s to the power 3 by 2. Now this is equal to half root pi over s to the power 3 by 2. This is what you get. Okay. Similarly, I want to work for the Laplace transform of t raised to 3 by 2. Now using that same formula, you have gamma of 3 by 2 plus 1 divided by s to the power 3 by 2 plus 1. Or it is, by using the same concept, you have 3 by 2 into gamma of 3 by 2 divided by s to the power 5 by 2, because 3 by 2 plus 1 results in 5 by 2. So you get s to the power 5 by 2, and that is equal to 3 by 2. And further when you simplify this, you can get this as half gamma of half over s to the power 5 by 2, or 3 by 4 root pi over s to the power 5 by 2. Okay. Similarly, let us work for the Laplace transform of t raised to 5 by 2. It is gamma of 5 by 2 plus 1 divided by s to the power 5 by 2 plus 7 plus 1, or it is equal to 5 by 2 into gamma of 5 by 2 you get over s to the power 7 by 2, or it is 5 by 2 into 3 by 2 into 1 by 2 into gamma of 1 by 2 over s to the power 7 by 2, or it is 15 over 8 root pi over s to the power 7 by 2. This is what you get. Okay. Now what we have to do is substitute all of these in this expression and try to simplify it. So you get the Laplace transform of sine root t as, yes, first the Laplace transform of t to the power half. T to the power half Laplace transform is half root pi over s to the power 3 by 2 minus 1 by 6 constant, keep it as it is. Now the Laplace transform of t raised to 3 by 2, it is 3 by 4 root pi over s to the power 5 by 2 plus 1 by 20, again constant, keep it aside. The Laplace transform of t raised to 5 by 2, it is 15 over 8 root pi over s to the power 7 by 2. Okay. Now further you simplify this to, you get it like this. Okay, and further if you simplify this, you get this as again 8 over here. Okay, so minus so on, let us continue that. Okay, now this is equal to half root pi over s to the power 3 by 2 minus 1 by 8 root pi s to the power 5 by 2 plus 1 by 64 root pi s to the power 7 by 2. Now I want to minus so on. It continues further. Now I hope it is seen there. Just 1 minute. Yes, see. You get half root pi over s to the power 3 by 2 minus 1 by 8, 2 4s are 8, root pi over s to the power 5 by 2 plus 8 8s are 64, root pi 1 divided by 64 root pi s to the power 7 by 2 divided by s to the power 7 by 2. Okay, now I can take 1 by 2 root pi s to the power 3 by 2 common. So what you are left with here? What you are left with? You have taken everything outside from here, so it will become 1 over here minus. You have taken already 2 outside, root pi is also outside, and s to the power 3 by 2 you have taken out. So what you are left with? 1 by 4s you are left with. Yes or no? So 2 is taken out, 2 4s are 8, 3 by 2 into s to the power 1, so it will be s to the power 5 by 2, right? Plus, you have only taken 2 outside, so you are left with 1 by 32, root pi is already outside, 3 by 2 is outside, so what you are left with? 1 divided by s square, just see, 1 divided by s square, s to the power, s square plus 3, 2 plus 3 by 2, what is 2 plus 3 by 2? It is 7 by 2, is it? So 3 by 2 you have already taken out, so you are left, you should get 7 by 2, so it should be s square over here minus so on. Okay, now this can be written as half root pi over s to the power 3 by 2 into 1 minus 1 by 4s plus from here I can take 1 by 2 factorial outside, means 1 by 2 factorial is 2 factorial only. Okay, so if I take 2 factorial outside, what you are left with? 16, is it not? So you can write it as 1 by 4s whole square, because it is 32 into, because it is 16 into 2, which is 32. 16 into 2, it is 32. Okay, so that it is 4 s square over here. So if I attach 4 to it and write it as square, it becomes 16 into 2, 32, which is there here, s square is also there, minus so on. Okay, I hope it is clear. Yes, now this is again equal to, I'll simplify it here only. Now this can be written as half root pi raised to 3 by half root pi divided by s raised to 3 by 2, and this is nothing but what? What is this? I'll just write it here, 1 minute. What is this? What is the expansion of e to the power x? What is the expansion of e to the power x? Or I should say, what is e to minus x? First write e to the power x first, you can easily write. So it can be written as 1 plus x square divided by 2 factorial plus x cube by 3 factorial plus x to the power 4 by 4 factorial plus so on, is it? Now I want in place of x as minus x, so you will get 1 minus x plus, because minus x whole square becomes plus x, so you will get plus sign, minus x whole cube, it becomes minus x cube, so plus, so all the even powers you will have positive and odd powers you will have negative, is it not? Here also you are having the same thing. In place of x you have 1 by 4sc, just see, 1 1, in place of x you have 1 by 4x with negative sign, 1 by 2 factorial is aside, in place of x square you have 1 by 4s whole square. Further terms you will get the same way. Okay, now this is nothing but, I'll write it in small this here. Now this is nothing but e to the power minus 1 by 4s. Why? Because you just refer the expansion for e to the power, e to the power minus x, you will get it C. Okay, I hope it is seen there. I will explain it once again. Just see here, up till here I think everyone has understood, up till here also everyone has understood. Now to get this expansion, the simplified form for this expansion, just consider what is e to the power x. E to the power x is 1 plus x square by 2 factorial plus x cube by 3 factorial plus x to the power 4 by 4 factorial plus so on, is it not? Now in place of that x, if you replace every x by minus x, that is e to the power minus x expansion, how it will be? Just write everywhere x, in place of x, x square. Minus x, so it will be minus 1 minus x, because in place of x you are writing minus x, plus minus x whole square you are writing, minus x whole square is plus x square, is it not? Yes, similarly minus x whole cube, you will have minus x the whole cube, is it not? Means what? All the odd powers of x, negative x will be negative, and all the even powers of negative x will be positive. So that is what you are getting here, is it not? Now just compare this expression with this expression. In place of x you have 1 by 4sc, 1 minus 4s, 1 divided by 4s plus 1 by 2 factorial aside. In place of x square you have 1 divided by 4s whole square minus so on. Okay, so you will have the same thing over here into e to the power minus 1 by 4s. So this completes the solution for this problem. Continue in my next class. Okay, thank you.